Hi, today I'm going to talk about the problem of interdependent pull requests. What do I mean by this? Okay, imagine the following situation. After you submit a pull request to a source repository, and before it is merged, you add a new pull request off the tip of the first pull request. Then the maintainer merges the first pull request but with some edits, and then pull request number 2 is no longer perfectly synchronized with pull request number 1. Maybe there is not necessarily a conflict in the sense of a Git conflict, but still it is not a valid pull request without some changes. So the situation can be quite challenging to notice, so the recommendation is to never do that. If you can, avoid interdependent pull requests. But if you have to, okay, then you would branch off the tip of the first pull request, you would branch the second one. But here is a video to show you what problems you might face. So it's not shown in the screen, but I'm going to be using the usethis package for this presentation. So the first thing you could do is to run the function library usethis, and then I'm assuming that you already have a local copy of the source repository, which you can create a fork first from the source to your user account, and then a local clone. All of that you can do with the function create from GitHub from the usethis package as well. So with that, now you are in a good position to run the function pr-init to initiate a pull request. So let's say that we initiate the pull request number 1, pr1. Then we do some work. Suppose that we add a new function f in the file f.r. When we do that, we save the file, we create a commit, and then we push that commit to GitHub. How do we do that? We can do it with the function pr-push. That function will also open a window in a web browser where we can see an interface similar to the one shown here, and we can check that the commit that we submitted to the pr1 branch in the repo ABC of the owner Mauro Lepore, in this case, is proposed to be merged into the master branch of the repo ABC of the owner and org. So that looks all good to me. We see green everywhere, which means that we are good to go. We could, create a pull request because there is no merge conflict. So we create, boom, we click here in the green bottom, and now let's assume that before that's merged, we start a second pull request. So we can do that locally again as contributors with the function pr-init, and then we give it the name, let's say pr2. So usethis will detect that this situation is not ideal and will ask you for confirmation. It says create local PR branch with non-master parent, and then you have to say, in this case, 2, absolutely, if you're sure that that's what you want. But generally, you don't want that. Generally, what you want to do is to submit a pull request, or each pull request of the master branch synchronized from the source repository. Okay, but let's say that we really want to do this, create pr2, and then we start working. Let's say that we already had this file f.r with the function f, and now from line 5 to 7 we add a new function g, that simply calls f of x. So we then save that file, create a commit, and we pr-push it to GitHub. Again, we are presented with a similar interface to the one that we saw before. We can check that the commit from pr2 in the repo ABC from the owner Mauro Lepore wants to be submitted to the master branch of the repo ABC of the owner and org. That all sounds good, and we create the pull request. But now, from the perspective of the maintainer, this is how things look like. So the maintainer might also run the function library usethis to start using the usethis package, and they can fetch the first PR. In this case, the first PR is associated to the number 5. So the first PR, the maintainers get it locally with the function pr-fetch number 5. And that brings that PR and creates all the wiring necessary for the maintainer to review it. Let's say that the maintainer decides to rename the function f to my f. In that case, the file may they might also choose to rename the file so that it matches the new name of the function. So the function was f in red, and now it's my f in green. And the file was f.r in the beginning, and now it's my f or my_f.r. So that's the change around the maintainer, and they save the files, create a commit, and then they push push sends that commit to the source repository. The maintainers have privileges to write to master, the maintainers, when they run push, then correct myself, that commit will be sent to our fork, to the fork where the pull request was submitted. But if they then merge that pull request, then they will be in the situation similar to the one shown here on screen. So if they, after doing the changes, they merge it, which I'm not showing here, then the history of this commit, of this repo, could be so. The initial commit here is a commit previous to this demonstration, so that's not relevant to our talk. And then this second commit is commit squash, really. So it kind of gets the commits that were submitted by the contributors, and the maintainer had the capacity to edit the commit message before merging those commits into master. So they wrote new my f instead of new f. And they thanked the contributor, and they signed off this commit with their first, last name, and their email. So now, again, from the perspective of the contributor could run the function PR. Say that they get an email saying that the PR number 1 was merged, and then they go locally and they run PR sync to get the commits that include that PR into the source repo. And when they run PR sync, nothing really obvious is shown as a problem here. But if we pay attention to the history of this repo now, we would probably see from the commit history that the files added by the last commit are not what we expect as contributors. So remember, as contributors, we had submitted this file f.r, and we now see that the file my_f.r exists here, and that it has the same function that we wrote in f.r, except that the name is different. So the situation has some duplication. So the file f.r is still there because it is in the PR2. So the commit that added f.r is still in this branch. And now, because we merged our branch with the function PR sync with the upstream master, is that we also have this squash commit that brings my f.r. So now we are with this duplication, and we need to kind of fix things here. So basically, in the next step, I'm going to show you how the Git history changes after all files have been modified accordingly. So what we as contributors could have done is to move the function g that we wrote in PR2, to move it from the original file where we wrote it, which was f. We should move it to my f. Then edit the function g to use my f instead of f, and then we would kind of remove the file f.r. So that would now leave the repository in a good state, and then we could then run PR push to send PR2 back to our fork. Okay, then the maintainer could review that. If they're happy with it, they could merge squash that commit. They would also say something that relates to the PR5, which is the previous PR, the one for the maintainer, for the contributor, but was associated to the number 5 as a pull request. Again, they might say thank the contributor, and also sign off that commit with the first, last name and email. And with that, PR2 would also be incorporated. So we can now locally, as contributors, we could run the function PR finish, which will do a really nice kind of cleanup. It will kind of switch back to master. Then from master, it will pull the changes from GitHub, from the source repo. And remember that pull is a shorthand for fetching the history of that repo and then merging it into the checked out branch. So basically this means that our master branch now locally would be kind of synchronized with the upstream master, and then PR finish also that leads the PR2 branch, so we are kind of back in a clean state. So if we see at the commit history here, let's go back one slide or two slides actually to show how messy the process actually was. But then after those pull requests have been squashed, merged, then the history is so that for each PR there is a single clean commit. So the repository before this demo started at this state where there was only one commit. Then the second commit was, starting from the bottom up, was the one included by the squash merge of the first PR, and then this third commit is the one that resulted from the squash merged of the second PR. So, and we can see here, what has been added in this particular last commit. So with that, we cover this scenario, the scenario that we want to avoid. We want to avoid interdependent pull requests, which is a situation where we usually kind of branch off a pull request off the tip of a previous pull request before it was merged. We want to avoid that because it can cause conflicts, and those conflicts are particularly challenging to solve because not always are so obvious, and you actually need to really read the Git history to see what changes need to be done before the second pull request can be merged. So, well, that's all I have to you today. Thank you very much.